Hey everyone, just give another minute or so before I start. Okay, so we're at the hour. So welcome to this AMA with delivery team. So we're here today with our monthly AMA to answer any questions people have about deploying GitLab or releasing our monthly packages as well. This time around, we've put together some slides as well to try and give a little bit of a background view of the things we're working through. Right now, we're really interested in scaling and how coding at scale is kind of feeding into how we can keep up our cadence of deploying and help us as we grow. So you see in the slides that we are not only deploying more frequently these days, but we're also dealing with more traffic than we have been in the past, which is great. And also more changes. So as we have more changes, even though we're deploying more frequently, the number of changes in each deployment is also growing, which adds some risk, but also is a good encouragement for us to move faster. So the more frequently we can deploy, then we can get these deployments down to smaller size. So those are the things we are sort of working towards. Please feel free to add in questions into the agenda as we go through, but I'll kick off with Michelle's question. She's not on the call, so I'll read this one out. So Michelle's asked, how do we prevent deploying something to an environment that will break another environment? For example, running a migration to drop a table would work fine on Canary and pass all the tests, but break production until the change has been made it to production. So what are some of the things we look out for as an engineer or things we can do to prevent this from a release deploy perspective? Myra, hand over to you for this.
Yep, sure, thanks. So for reference, I think it is useful to explain a bit how our deployment process goes, particularly between Canary and production. So when updating Canary, we first execute the regular migrations, then we update Canary fleet. Then we do another things such as executing the QA and let Canary sit for a bit before promoting to prod. When we promote to prod, we update the prod fleet and then we execute the post migrations. For the particular example of dropping a table is only allowed to be executed in post migrations after the prod fleet has been executed. We don't drop tables on Canary because that is risky. Because that will be done with regular migrations that are updated before the Canary fleet. It is a bit complicated, but that will be like the whole process in a nutshell. Then another sensitive operation would be dropping a column. Dropping a column is not as easy as I'm just going to drop a column. The process is spread across 3 releases, which basically involve first ignoring the attributes. Then in another release, we actually drop the column. And then in the third release, we remove the ignore column operation. Our database documentation actually has like great examples of these sensitive operations that can be prevented from a database and deploy perspective. And also code that could work in different states is something to look forward or to look out when it comes from an engineer perspective. And with that, I basically mean that when we are updating our production fleet, we update, the nodes are updated at the same time, but some nodes can be finished earlier than others, which also could lead to unexpected failures. And this is something to consider for. And I think the next is Sid.
Thanks. Are we keeping the architecture components list up to date? Because I think I'm seeing stuff that isn't in the overall list of architecture like Plant or UML?
That's a great question. I would hope so. We should be. We'll certainly take a look and see if we have any gaps in there and make sure it's part of our process. Yeah.
Cool. Thanks, Amy.
Thanks. Cool. Does anyone else have any questions?
Amy, you refer to like we're having more and more changes in GitLab, so want to deploy more frequently. What's the expectation? Where do you want to be? I don't know, halfway through the year, end of quarter or end of year, or whatever goals you've set, like, and how we're gonna do that.
Absolutely, yeah. So at the moment, we are doing well with our MTTP target at 12 hours. Rollbacks is the sort of the next big enabler for us to trend that one down. So for two reasons. One is it will allow us to recover from incidents more quickly, which frees us up to do more deployments. But also it allows us to take a little bit more risk with our deployments because we can recover more quickly. So the big goal will be to be able to go below our MTTP 12-hour target and look to reduce that further, hopefully, which will hopefully then get us back on place with the number of changes, the smaller deployments. Alongside that, the migration for Kubernetes is going well. So the big goals, we have some big targets there, which is to complete the stateless Kubernetes migration and then start on the stateful ones. So those will all tie in. So we should see significantly faster deployments by the end of this year with rollbacks running off Kubernetes as well.
Cool, thanks. And maybe that's super obvious to you, but I think, are we never going to get into a state where we deploy every change because it's almost too much work and we have too many changes and it wouldn't be efficient? Or is that an aim? It's
definitely the goal. Yeah, I don't think we'll get there this year, but yeah, I think that's absolutely the goal. Like, say, just in terms of the fast feedback and like kind of concept of the smaller the batch, the safer a deployment. Like the ultimate small batch is one change. So yeah, that's absolutely the sort of the biggest goal, but not this year's goal.
Yeah, that makes sense. Thank you.
Thank you. Are there any other questions? So one question I had that I was curious about was, which I was kind of chatting with Myra about earlier, it was interesting to me as I put these slides together to come across the incident I referenced in there, which had one of our recent database migrations failed, not because there was anything wrong with the code, but on slide. Yeah, on slide 2, there was a database migration failed, not because there was anything wrong with the code, but because it couldn't get the locks it needed because there were so many other things going on with the database. And I was curious, as talking to Myra earlier, about, is that the only incident we're aware of that had a similar kind of traffic related problem related to it?
So it hasn't been the only one. For the last 2 weeks, I think we have been having at least 2. And these have been associated to high traffic tables. So high traffic tables are tables that have a bunch of records and that are usually frequently requested by our application. Examples of that are the projects and the namespaces table that has, well, I don't remember the exact amount of records, but it goes above millions, and it also has like a size that goes in, I think it's in gigabytes now. So the operations that were doing these migrations were actually quite simple. We're adding just a column, yeah, I think both of them were adding a column, but it couldn't be done because to add a column, you need to acquire the lock. And there were other transactions running at the same time, high long transactions that were also acquiring the locks, so the migration failed. Now, what is curious is that this operation wouldn't have been a problem. Like 6 months ago, or perhaps 8 months ago, but there has been a problem now. And to my knowledge, and I think some database team members are here, we are exploring like where are these high long running transactions are coming from, because we are still not sure. So that is a corrective action for one of those incidents.
Yeah, exactly. So what we're seeing increasingly is those longer transactions, and it could be as easy as having one of these steps basically preventing us from getting those locks and sort of causing those troubles. So we're basically figuring out which of these transactions are causing this, and what are the patterns that we need to change. And this is something that we can see with increasing data size. Some of these patterns, they just take much longer than they did before, and I think this is what we're seeing, and what we also need to address. But first of all, we need a bit of better monitoring, I think, for the transaction length, and also where they're coming from, and then we can chase them down.
Nice, that's great. Thanks for sharing, and appreciate your efforts here. Like, definitely, it's interesting for us as we go into our rollbacks work, as we kind of look closer and closer at the database migrations. Like, certainly those are the things that have so far prevented us from just having rollbacks for free. Is how do we actually manage rollbacks safely around changes to the database? So definitely appreciate all your efforts on this stuff. Something I put
we're also working on. Sorry, just to add to that, we're also working on the database testing end, so that we are better in better shape with testing migrations before we deploy them, before we even merge them, right? So much earlier in the cycle, and this is gonna help us, I think, with a lot of problems that we recently had with migrations. However, there are still problems like we just talked about with locks and that are related to the production traffic that is coming in. And this is something that the database testing that we're currently working on is not going to help with, because this traffic, it only happens in the production environment, and we will have to find other ways to deal with that.
When we were investigating the state of the art of the deployment and rollback in the industry, there was this interesting concept of having a shadow canary, or even a shadow production. The problem is that it's really expensive. Well, it will help us in this type of situation, because the point is that you may have settings in your application, like an environment variable, that tells the application to never reply to any incoming request. And so some of these companies are running, basically they have a proxy in front of the application, and they send the traffic to real production and to shadow production, so that both process the same amount of requests, exactly the same request, and they have dedicated database that are kept in sync, so they can test things like that, right? So they have an environment that never replies back to the client, but there they can run, for instance, migration in advance. So say, let's see how this migration behave on real production load. But yeah, it's just doubling the cost of production environment. So
you can also do it on the database level only. So we would also be able to sort of capture the traffic that's going on the database and then replay that in another database, so that you don't have to replicate the whole environment. That's definitely a good idea, for sure.
Nice. Yeah, that sounds excellent. Yeah, definitely. I've seen places where having a migration, in fact, a full kind of separate deployment pipeline. So with a separate migrations environment to test against like a kind of production-like environment, and then deployment separately, which I suppose also makes rollbacks easier as well. Something I added into the slides, but only very briefly, was the expand and contract pattern. Alessio, do you want to just talk to us a little bit about how you ended up, like I know you wrote some examples out, which I've got linked in there, but maybe just give us a little overview of like why this matters and kind of what we might do to adopt this.
Sure. So this basically is the extended answer to Michelle's question, the first one. So the point is that when you have an HA environment and you want to have zero downtime upgrades, like the feature that we are providing to our customers and what we are doing on GitLab.com, you have to deal with a mixed state. So you have to deal with the fact that at a given time in production environment, there could be different versions of the application running. So this means that you have to kind of break down every type of feature, every type of changes that will affect storing data, reading data, basically everything that introduces a breaking change must go through these three phases, which are basically this is expand and contract, but the phase, let me try to, yes, is expand, migrate, and contract. And basically database is the easier one because with post-deployment migration, we found a way to have those three steps in a single package, so with a single deployment. Because basically, I will use the database migration as an example because it's easier and is more common, easier to understand. So in database migration, the expand phase is the regular migration. So we run it before the deployment. Then we migrate the fleet. So every machine that is running version N start running version N+1. And then when we are sure that all the fleet is running version N+1, so it's the new version of the application and it is working correctly, we can contract, which means, for example, removing a column. So database is easy because basically we can do this in one single package. When it is not database related, it requires basically 3 milestones. That's the real problem here because we want to give zero downtime upgrade for our customers. And so we could do this in 3 days at GitLab.com, because even less than 3 days, just 3 consecutive production deployments. But because of the on-premise installation, we need to split this over 3 milestones. And basically, that's it. Every time we want to change something that will not be able to run at the same time with old version and the new version, we have to think about how can we split this change in 3 releases. Another example which doesn't rely on database is something like, so often happens something like this, that we change markdown parsing. So this is a common source of incident. We add a feature or we change something in our markdown engine. And as soon as canary machines start processing the new data, they will save markdown preprocessed information on cache with the new format. And when a production machine that is running the old version pickets, it doesn't know what to do with it and it crashes. So what we do in this case to avoid it is that we first implement the reading. So we need to make sure that we ship something that can read the new format without writing it. Then the next release, when we know that the reading part works, we can ship the writing. And then the third part, we remove the backport functionality. So after the third release, everything works with the new implementation. And that's it, basically.
Nice. Thanks for going through that. James, do you want to verbalize, take over writing?
Sure. Yeah, and I'll type it in for sure. But yeah, thank you for explaining that, Alessio. That really clarifies some of the things I've been trying to understand is how we were handling some of our stuff. One of the things that, based upon what you just explained, that comes to my mind that I'm just kind of curious if it's even come across. Say we have a, 3 dots for, we have X.Y.Z, right? And that's that's for the customer, et cetera, right? But then and we can only do, like you just said, right? We can only do something for the customer this month, this month, this month. But have we ever thought about having, you know, like a .alpha, and, you know, that is what happens internal. And so, for instance, what you just described, let's say that I roll out a change, and then the next release, I roll out the next piece, and, you know, because it requires 3 releases. So we've got 3 releases internal, and then we got 3 more releases internal. And then when it comes time for the customer release, those are all packaged together in a single iteration, right? And so it's almost like a, you know, it's almost like change all in the same list, right? And so we may do it iteratively internal, but outside they're going to do it all in one lump sum. I'm just curious if that's ever come to mind.
Okay, thanks for your question, James. So we had this conversation around how can we speed up adoption of new features without breaking into 3 milestones, because that's basically the problem. So I proposed something. I can find the link of because there's a conversation on issue, so I will find it so that I can link it here. Basically, this is already complex, so adding this extra complexity on top of it doesn't really help. But the point is that, yes, we can do it, depending on the type of breaking change. The idea is that you can ship a breaking change behind a feature flag. Okay, the feature flag has to be disabled by default, which means that on gitlab.com, we deploy it, we enable it when we think there is time to enable it, and we can have all the features ready in 1 day, whatever. In order to speed up this for our customer, we could leverage post-deployment migration. So feature flags are stored in database, and post-deployment migration is a synchronization point in time that tell us all the production fleet is upgraded now. So this means that you could ship the feature with disabled with the feature flag, wait till the end of the deployment, and automatically by post-deployment migration enable the flag. We've never done this, but in theory, it could work.
Thank you.
That sounds cool. We should try it. We could try that right on GitLab.com, right? That's kind of a nice test ground. Nice. Thank you for asking that, James. Are there any other questions? No? Okay, fantastic. Thanks so much for coming along, everyone, and thanks for all the questions. Hopefully we'll see you all next month. Oh, thank you. Goodbye.